In this video, we will be discussing about Q, right? So let's see what is Q, right? So Q is a linear data structure which follows the principle FIFO, that is first in, first out. It is a linear data structure in which I can insert my element from one side and that will go in a queue, and I will dequeue my element from the other side, right? So in convenience we take front for deletion of element, which is also called dequeue, and we take rear for insertion of element, which is also called in queue, right? Now let's discuss how we can implement a queue using array, right? So suppose first I have to write a function for in queue, right? So suppose first I will declare my size. So let's take an array of size 5, hashtag define and 5, and then I will initialize my array in queue and right, and then I will take a variable front and rear, which will be initially -1 int front is equal to -1 int rear is equal to -1, right? -1, suppose this is my index 0 1 2 3 4 5, so this is -1. It is for convenience that queue has not been started, right? Now I will write my function void in queue, right? Now what I will write, I will say if my rear is equal to n minus 1, right? So suppose my size is 5 and suppose this is for 6, right? Let's remove this here, right? Now I have filled my element up to here, so it will not go ahead. So I will print in this, right, overflow condition. Then else, then what I will see, else if front is equal to -1 and rear is equal to -1, front is equal to -1 and rear is equal to -1. So suppose I am at here, right? So what I will do, what I will do, I will take my first element, right? I will make my front and rear. Suppose initially my front and rear are -1, then I will make my front equal to rear equal to 0, and then I will fill my first element, that would be q, rear will be what? This will be x, right? The variable that I will take, right? Then I will close and at else part, right? Now suppose my first element is filled at first index, my first element is given in the queue, then at else block what I will write, I will increase my rear, so I will write rear plus plus, and then I will write q rear is equal to x, q rear, right, q rear is equal to x, right? This is the logic for enqueuing an element, right? Giving an element to a queue, right? Now we will discuss about how to dequeue an element, right? How to remove an element, right? So as this is my queue, first I gave 9, then 8, then 7, then 6, then 5. So when I will dequeue, I will remove first this element, then this, then this, then this, right? So let's now code for dequeue, right? So I am erasing this, right? I am writing this thing here. Right, this is front, this is rear, and I am erasing this. Right. So what I will do? I will write code for void dequeue. Right. So what I will write, if my front is equal to -1 and my rear is also equal to -1, so basically I am at here. So here there is no element, so it means it is under flow condition, list is queue is empty, right? But if else if suppose I have reached here, right? Suppose I have, this is my queue, right? So what I did, first I gave 6, then I gave 7, then I gave 8, then I gave 9, then I gave 10. So first I gave 6. So I will remove 6 1. Then my front will go to here. Suppose my rear is at 8, right? Then I remove 7, so my front will go here. So there will be a condition where front will be equal to rear. If this is the condition, that means in my queue there is only one element, right? So what I will do, in that condition, I will make my front equal to rear equal to -1, right? Now else, if my front is below here and rear is here, right? So what I will do, I will go ahead, right? I will give my front ahead. So what will happen now? My front will go here. So this element is of no use, right? Right. And the dequeued element I will print is printf. Dequeued element will be %d, right? A stack, sorry, q front. This is my dequeued element, right? So now I am erasing this and I am writing code for now display. Suppose I want to display all these numbers, so what I will do, right? So let me erase this. Now what I will do, I will write my function for displaying the elements in my queue, void display, right? So what I will do, I will initialize, I will take a variable first for my loop, and then what I will do, if my front is equal to -1 and rear is also equal to -1, that means my queue is empty, right? Else what I will do, I will run a loop, right? For I is equal to front, right? Then I is less than rear plus 1, right? Rear is here, right? this is my real, right? And real plus 1 will be this, right? Suppose this is 5. So once I will become 5, I will become then 5, there is of my loop will be of no use, right? I will get my I equal to 4 and real plus 1 is 5, right? So I will print, but then when my in updation when it will become 5, then I will go outside loop, right? So here I will be doing I plus plus, right? And I will be printing printf percentage d, right? Q of I, right? This will what I will print, right? Now suppose I want to pick an element, I want to see the suppose I want to see an element which is it's my first element, right? So what I will write, void peak, and I will write here printf percentage d q of front, right? So what I will get, I will get my first element, right? This is what my peak function will do, right? Now let me erase this. We will be now discussing about how to implement a queue using linked list, right? So let me discuss about other thing, how to implement a queue using linked list, right? So let me erase this first, then first of all let's discuss what it will be in a linked list, right? So I will have in the pointer which is front, right? Front will point to my first node. Suppose this is, and this is 250, this is 400, right? Here will be my datas, and here it is pointing to the next node, right? And here it is 0. But when I will insert, right? So first this was created, right? Sorry, first this was created and this is at last. So insertion will happen when to the last, right? So here I will insert, right? And this is 0 and this will be having suppose 500. So here I have to store 500, right? And I will be having a tail which will point initially toward here but then towards this, right? So it follows what? FIFO, right? First in, first out. So what happened initially? First in means in a queue, suppose these are my numbers 7, then 6, then 8, right? So it is like a first come first serve, right? Suppose this came first, so this will be also removed first, right? Now what I will do, suppose I insert from here, so I will remove the one who was inserted first, right? So I am writing code for in queue, right? So let's define first a structure. So I am declaring a pointer a struct node asterisk front and then a struct node asterisk rear, right? This is rear, right? And then I am writing my function void in queue, right? Void in queue int x, right? Void in queue int x, right? I am removing this. So here I will write first I will declare a pointer which will store address of my newly created node. So this will be a struct node asterisk new node, and now new node I will store my first created. Here I will store struct node asterisk malloc, sorry, small m malloc size of struct node. So what will this do? This will create a node and it will return address in new node, right? So new node will keep the address of my newly created node, and then I will insert my data. So new node will go to the data part, and here I will store my x, and new node will go to the next part, and here it will store initially null, right? Then if front is equal to 0 and rear is equal to 0, so what, my queue is empty, right? So what I will do, I will give my front equal to rear equal to new node, right? So what will now happen, my front new node will point suppose here, right, and front will also point here, rear will also point here, right? Now in the else part, when I got my first element, what I will write in my else part, what I will write, I will write rear next is equal to new node, and then rear is equal to new node. So what happened now? A new node is created. Suppose this is 4 and 0, and this is 300. So here 300 is stored, and this is pointing toward here, and at rear 300 is stored, and this is now pointing here. And this is how my upcoming nodes will be done, right? So this was code for in queue, right? Now discussing about the queue. So what I will do now, right? So now let me erase this. So let's discuss about how to write code for DQ and display, right? DQ and display. So for display, what I will do, I will initialize a pointer which will point towards data type, which is a struct node, which will be the data type of my nodes, right? A temp I took. Now if front and rear will be equal to 0, I will say my queue is empty, right? But in else part I have a proper queue. So what I will write, temp is equal to front, right? And then while temp does not become null, I will print. So printf %d temp data, and then I will make my temp ahead. So I will write temp is equal to temp, and it will access to the next member. It will take the address and it will point toward the next node, right? And in case of DQ, I will write void DQ. What I will write, I will again take a pointer which is a struct node temp, right? This is the same thing I will do, and then what I will do, I will say my temp is equal to front, right? Now if front and rear are 0. So I will say my list is empty, but in else part I have a proper queue or proper list. So what I will do, I will write printf %t, right? What I will write, front, it will access to the data part, it will print that thing, and then what I will do, front, I will make it ahead. So by accessing the next part, I will make my front points toward the next node, right? And the temp is pointing towards the front. So I will write then free temp. So that particular node will be deleted, right? And in case of peak, suppose I want to see only the first element, right? Sorry, I was wrong at that time. The first element, yes, I was right actually. The first element is, suppose I have a linked list like this, and this is front. So this is my first element, and this is the last, and insertion was done to last element, right? Now at peak, what I will do, I will simply write this. I will only print the first data, I will not delete it, right? So this was the code, and this was for today.